Thank you for joining our Technical Insights, Achieving SAP Workload Resilience with Microsoft Azure and SUSE virtual event. We will get started with the presentation in a few minutes. Thank you. Thank you again for joining our virtual event. If you have any questions throughout the presentation, please use the questions section on the control panel and we will answer your questions at the end of the presentation. I would like to introduce our speakers for today's session, Dennis and Sherry.
Hi, this is Dennis. I'm Principal Software Architect at Microsoft. I'm part of SAP engineering team that focuses on designing and creating reference architecture for SAP Workload on Azure. I usually focus on high availability and disaster recovery, deployment framework, and the QA testing for Linux distros on Azure. Sherry?
Hi, this is Sherry Yu from SUSE. I'm a SAP solution specialist at SUSE, focusing on the SAP HANA and S/4HANA migration with a focus on the deployment on the hyperscalers.
Welcome everyone, and thank you for joining today's webinar. So in today's webinar, the agenda of today's webinar is to talk about how to achieve resiliency on Microsoft Azure running on SUSE Enterprise Linux server. So in today's agenda, we will be covering different aspects on how to increase the resiliency for SAP workload, which requires designing and availability architecture for SAP workload on Azure. We will touch upon some of the best practices that you could use to enhance this SAP workload resiliency on Azure. And then Shell will talk about some of the best practices that you could use to reduce the plant downtime, which you could leverage at the OS level, and some of the roadmap updates for SAP application. So just wanted to start with the saying that on Azure, so there is no denial that in a public cloud, the occasional downtime due to hardware or power failures is inevitable. So it's crucial to design your SAP workload in a way that can withstand such hiccups. So in this session, we want to cover that aspects where how the customer could basically set up their SAP workload in such a way that in case of certain hiccups, they basically able to withstand, their application is not impacted, their business is not impacted. So here we will be first focusing on at the infrastructure layer, because we will be covering in today's session, we will deep dive in details for enhancing workload resiliency, where we will explore various strategies on both at the infrastructure level and how one could achieve at the application at the operating system level as well, to ensure that the SAP application remains robust and reliable. So before I jump into going in details about talking about different deployment options and how one could achieve the resiliency at the infrastructure level, I want to deep dive and give some background on how we basically design our reference architecture on Azure. So when we design our SAP workload on Azure, we have three guiding principles. One is basically we basically focus on the comprehensive solution, which means like we support all major SAP certified operating system. That includes Windows and SUSE and other Linux distros as well. Then we basically make sure that all the SAP product is basically supported on Azure, and the availability options are available and should be configurable on Azure. That includes like very SAP NetWeaver, Business Object, legacy database, SAP HANA database, and even with regards to SAP HANA database, we try to focus that we provide all the solution with regards to HANA scale up with HSR, HANA scale out with standby, and HANA scale out with HSR as well. So this basically talks about the diverse portfolio that we have, and that we try to basically keep updating that reference architecture to basically provide the advancement on what we deliver on Azure. So the second key principle is maximizing uptime. So over the period, like Azure region has expanded, we continuously enhance uptime and resilience mechanism. So with that, we basically evolve our high availability strategy as well. So initially, we have created a reference architecture with regards to the availability set that distributes a VM across different fault domain. And then with the introduction of availability zone, we develop a zone resilient architecture for SAP workload. So we keep on optimize our architecture based on the need of the customer, as well as the advancement that we do on Azure as well. And then there is a continuously optimization with SAP and SUSE. So we collaborate with SUSE engineering to improve cluster stability and enable faster failover. We basically work on optimizing configuration and introduce simpler edge setup. Something like SAP HANA SRNG or SAP Simple Mod, so which we will be covering later in this session. And then the third pillar is third guiding principle is lowering the TCO. So there are basically, we hear the feedback from the customer along with the performance optimization. There is a concern on lowering the total cost of ownership as well. So we try to make our investment in providing a cost optimized scenario. So some of the cost optimized scenario which we deliver is like support of multi-thread and in an existing 2-node cluster, so you can deploy multiple SIDs in a single cluster. Then there is a support of additional dialog or other instance in a cluster. So with regards to, so along with this this guiding principle which drive us to create a reference architecture on Azure, I will try to deep down like how we can basically achieve that resiliency by choosing different deployment options based on the customer need. So on Azure VMs, for the one who you are deploying or worked on Azure, they know that VMs are usually deployed regionally or zonally on Azure. Depending on how you want to configure your SAP workload, you can choose one of the deployment options. Initially, when Azure was available to the customer, there were only regions with no availability zone. So when there was only region, customer could select a region, the VM will be deployed in that region. But now, in order to basically provide a resilience for that application at the infrastructure level, because of some hardware failure or platform maintenance issues, we introduce a construct called availability set. So when a customer deploy a VM in a region, they can deploy in availability set. So availability set helps so availability set has become a synonym of a regional deployment. So over the period of time, when someone says my VM is running in availability set, it means the VM is running as regional VM. So when a VM is configured in availability set, VMs are distributed across a specified number of fault domains and update domains. So this helps to ensure that not all instances of your SAP systems are impacted by hardware failure or maintenance events. So what I mean by fault domain and update domain, you can visualize fault domain is basically, so we have a cluster. So fault domain is basically a rack, one rack in a cluster. And then in each rack there you have different nodes. So each node is basically described as an update domain. So when a VM is deployed in availability set, the platform maintenance happens at the update domain level. So at any given point of time, no two update domains are updated at the same time. So you get basically, so if there is some issue on a platform maintenance in one update domain, your other VMs are not impacted. And then secondly, as the VMs are distributed across fault domains as well, if there is some issue at the rack level where there are multiple nodes, if your VMs are distributed, if your SAP system are distributed across different fault domain, then it will be distributed. If there is an issue on one fault domain, there won't be your other VMs are not impacted because of that. So that's the concept of fault domain and update domain. Then over the period of time, as Azure has expanded its footprints and basically we grew and introduced availability zones. So we introduced an architecture for SAP workload that can be spanned across availability zone as well. So in availability zone, VMs are spread across different AZs. This provides the higher resiliency by ensuring that the VMs are located in a physical separate location within an Azure region. So when you deploy an SAP system, you try to configure your hybrid SAP system across availability zone. You could choose best to availability zone that meets your need based on the latency and other aspects. Then recently we have introduced a new deployment option called virtual machine scale set. So this is a new deployment option, and for a customer who is deploying a new SAP system on Azure, we basically ask them to configure their SAP with virtual machine scale set FD equal to 1. So when an SAP system is deployed in virtual machine scale set, so what virtual machine scale set is, it is used as a deployment framework. So in general, virtual machine scales has many other features as well, while scaling in, scaling out, and other orchestrations that could be done using virtual machine scales. But for SAP workload, we support only as a deployment framework because scaling and scale out doesn't work out of the box for SAP workload. So we are using virtual machine scales as a deployment framework. So when I say as a deployment framework, what one could achieve with virtual machine scale set is like when you deploy your VM manually in a virtual machine scale set constant with FD equal to 1, you could choose on which availability zone you want to deploy your VM. So alongside where you're choosing the availability zone, when you deploy multiple VMs in the same availability zone, what virtual machine scale set do at the backend, it will try to max spread your VM on different fault domain on best effort basis. So you could see it's a combination of availability set plus availability zone. Currently the supported mechanism of virtual machine scale set is FD equal to 1. I will be covering more details in the next slide. So in this virtual machine scale set, so there are two orchestration mode, uniform and flexible. For SAP workload, we basically support only flexible orchestration for virtual machine scale set with FD equal to 1. So what FD equal to 1 signifies is doesn't mean that all my VMs in virtual machine scale set lands into a single fault domain. It means that with FD equal to 1, when you describe that or when you define FD equal to, it means the scale set will take care of max spreading of VM on different fault domain on best effort basis. So what I mean by that, let's take a graphical representation of an SAP, typical SAP system like NetWeaver system or something. So it has database, central service, and application layer. So you create a construct virtual machine scaleset. So it's basically a resource that you create. Virtual machine scaleset is a resource that you create at on Azure. So you create a construct virtual machine scaleset. You select a zone on which you want to deploy your VM. You define the max spreading FD equal to 1, and then you basically configure your VMs manually into virtual machine scaleset. So when you configure your VM, you select different deployment option. In that, you select virtual machine scaleset and select the virtual machine scaleset that you have done previously, and then you select the availability zone. Now, when you deploy when you deploy multiple VMs in the same availability zone that is part of the same virtual machine scaleset, what happens is like that virtual machines will be distributed across different fault domain within the same zone. So now if you look into SAP workload, the primary database and secondary database is span across availability zone. So you have your primary in availability zone 1, database secondary in availability zone 2. Same with central service, AS in ERS is configured in different availability zone. Now, when you configure application server, so for a given SAP system, you might have more than 2, or sometimes customer have 10 application servers. So in that, distribute 5 application server on each availability zone. So what when you deploy these VMs in a virtual machine space, what it will do is like it will try its best to max spread this multiple instance of application server in different fault domain. But it will be in best effort. So when I say best effort, is basically if there is some capacity challenge with regards to some capacity is not available in particular availability zone, it will not fail, but it will try to land your VM in the same fault domain. But it will try its best to max spread the VM on different fault domain. So if you see the application layer are on a different fault domain. So there is no concept of update domains on virtual machine space. So you have a question that if there is no concept of update domains, how the platform maintenance works in this case. So in virtual machine space, platform maintenance work at fault domain to fault domain level. Okay, so that's the reason why your VMs are distributed across different fault domain. So at any given point of time, if there is platform maintenance happening at one fault domain, the other and there is any issue, other fault domains are not impacted. So if we want to compare it, how it is different from availability zone, because if I'm trying to deploy in availability zone, I'm trying to use 2 availability zone, and then I'm trying to configure all my VMs in that particular availability zone. So in availability zone, what is basically the challenge is like each VM in availability zone is treated as a single instance VM. That means if I'm deploying my SAP system, my each VM is independent. So infrastructure won't know that this belongs to a single SAP system. So it could happen that multiple VMs of the single SAP system would be landing into a single fault domain. So there is no construct to orchestrate that behavior. So with virtual machine spaces, what it does is like there is an orchestration which help you to distribute your VM on different fault domains. So customer do not have to do manually anything. It will be taken care by the scale set level where the VMs are distributed across multiple zones, and you can even in the zone it will be distributed across different fault domains. So now so with all this, so this is our recommendation that any new deployment with regards to SAP workload should be deployed in virtual machine space. The reason also being that all the future advancement or features and everything is basically being worked upon on virtual machine scale set. If your current availability set is basically you won't be getting more feature because there is no advancement in feature development in availability set. So there are some features that are available right now, like on-demand capacity reservation. So that is not part of availability set, so that you could leverage in availability zone or in virtual machine scale set. Second thing is like over the period of time, as I mentioned, that initially Azure was offering only regions, but as we grew, we started offering zones. So when availability zone was basically configured, as that is a regional construct, when you have multiple availability set of a single SAP system, it could land into different physical location. So there was a concept called proximity placement group that basically anchors everything into a single location. That is basically that restricts the entire deployment into a single location. Now, because of that, if you will feel a challenge on getting newer capacity for the same SAP system, or you won't be able to change the VM to a newer generation SKU. The reason being, as the configuration is now getting restricted to a single location, uh, newer SKUs are part of a broader data because in Azure, the zone are basically a construct that has a single data center or multiple data center in a single zone. So it could happen that if you are restricted into a single location and there is a new VM that is provisioned in different data center, you won't be able to leverage that because of the restrictive nature of your deployment. But if you are expanding, if you are doing a zonal deployment, if you are using virtual machine scale set, with zonal deployment, you can basically resize the VM to a newer SKUs as the deployment is not restricted. So as we covered this at the infrastructure layer, how you could deploy your SAP workload across availability zones in virtual machine scale set. But now if we span into each layer of SAP workload, like database, central service, and application, how you could achieve a resiliency at each layer. Uh, so for SAP database, let's take, for example, HANA Scale Up, where you have primary HANA database and your secondary HANA database, which is being replicated across different zones, and you are using a pacemaker set. So the typical configuration should like recommended configuration should be you deploy your SAP system in virtual machine scale set, where you deploy your primary HANA in availability zone 1 and secondary HANA on another zone. You automate the HANA failover using a SUSE pacemaker cluster with SAP HANA SRNG resource agents. So this is the new resource agent that was recently introduced. So what is SAP HANA SRNG and what is the difference with the previous resource agent? So with the introduction of SAP HANA SRNG, there are certain features that was delivered with regards to enhanced resiliency. There was a faster payload and some of the simplified configuration. So when I say like the enhanced resiliency, it's basically it handles the short-term outage of HANA tools and communication with the pacemaker backend more effectively, reducing some downtime risk. And when we say faster failover, in a scenarios like you are using like NFS file system for HANA, so, and you are monitoring this file system. So in a scenarios like file system failure or unresponsive HANA instances, SAP HANA SRNG resource agent will make a quicker failover for both scale up and scale out. And when I talk about the simplified configuration, it basically reduces the complexity by having an identical software package for both scale up and scale out. So earlier with SAP HANA SR, there was two packages, one for scale up and one for scale out, but now it is clubbed into a single package. So it simplifies the configuration. And then how to increase the, like, these are like at the application layer. That's how you basically improve the resiliency for your application. There is another point that one could take care of is to integrate SUSE checksum. So as you know that when you have configured your HANA in HSR and pacemaker, but index server, when there is a crash of an index server, so HANA has its own mechanism to restart the index server of its own. So instead of, and it's very quick. So earlier, what used to happen is like as the restart was happening very quick, pacemaker was unable to detect that restart, and instead of doing a failover, all the load data load that has happened in memory will basically has to reload again because the index server has restarted. So it basically impacted the customer because now the business process has slowed down and things like that. So it was basically advised that instead of doing this, it's better to fail over because now your data is already preloaded into another instance on the another node. So there is a hook that was configured, and it was help you to basically perform faster failover. So it basically identifies this index server crash, and then it performs the failover to another node. And then the second layer is with regards to this SAP Central Service. So same, SAP Central Service, AACS and ERS deployed across different zones. And you can configure this into SAP Central Service using simple mark architecture. So SUSE has recently released this simple mark architecture where you don't have to manage. It's a simplified setup where you don't have to create a cluster resource to manage the file system. So the file system you could basically put in etcfs tab, and then there is a new resource agent that is introduced, which basically takes care of detecting where AACS and ERS should run. So it simplifies the setup, it improves reliability, and it basically improves the better resource management. So when I talk about this, both SAP HANA SRNG and Simple Mount, they will be the only supported option going forward in /16, but it is currently available in /15 versions as well. And then with regards to SAP application server, so there is no high availability SAP application, but the redundancy of SAP application server is could be configured by installing multiple application server on different VMs across different availability zone. So you deploy your multiple SAP instance in different availability zone and virtual machine scale set. So I will just ask Sherry to basically provide more details on this SAP HANA SRNG.
Yeah, thanks, Dennis. Yeah, as Dennis mentioned, the SAP HANA Resource Agent with a code name NG. If you are not familiar with this new solution, I'd like to provide some context. This is a new resource agent based on the past over 10 years of work. So SUSE started working on the HANA HA solution by working with SAP. So they started with scale up because that's the first HANA deployment option. And so HANA, SAP HANA SR is for the scale up. And then SAP started supporting scale out deployment architecture. And then SUSE released the HA solution to support that scale out. So so we released a separate resource agent with the name SAP HANA SR-scale out. So those are the two separate code base over the past 10 years, and which means that every time when we improve scale up, sometimes the same improvement can also be made to scale out. Then we put separate improvement to scale out resource agent. However, we are now at the point that we want to review what we have done and put the best effort for the next 10 years to come. And then we decided to consolidate both code bases and into the new resource agent with a code name NG. NG stands for Advanced Next Generation Interface. So the new resource agent would be named SAP HANA SR-NG. And it's already available, supported in /4 SAP 15 Service Pack 4 or newer. However, if you are using the classic deployment, they would be supported, to the end of the lifetime of /4 SAP 15. So there's no need for existing installations to upgrade. If there is no like technical issues with your existing deployment. And Dennis already mentioned the benefits, right? Some of the benefits like faster failover and a simplified configuration. But I want to highlight, because some of the SIP attributes, right, are not fully backward compatible. So there is a migration effort. If you want to migrate from your classic setup to NG setup, but we are providing a live in-place live upgrade procedure. And so I will have a slide later, right, to point you to that documentation.
Thanks, Sherry. So now, as we looked into different like in the infrastructure layer, how you could choose best deployment option to configure your SAP system, and then we have looked into what you could do at the application at the OS level to increase the resiliency by configuring pacemaker cluster with a latest up-to-date resource agent that is available. I want to touch upon one of the other architecture which which many customers use, like when they are using HANA deployment with ANF. So ANF is basically Azure NetApp files. So they want to their HANA volumes on Azure NetApp files. So earlier when the Azure NetApp file with application volume group was for HANA database required proximity placement group to identify where my VM is running, and based on that location, it will try to configure the Azure NetApp volumes in the closest proximity of that particular VM. But as there was a huge reliance on proximity placement group, and there were challenges associated to that as well with regards to at the VM level, recently there is a feature called extension 1, which is part of extending the existing feature on SAP HANA, where one could basically deploy volumes across availability zones. So now you could choose availability zones. So earlier there was no provision to choose availability zone for ANF volume, but now one could choose where they want to deploy their volumes in which availability zone, aligning with where their VM is running. So you can now place your volumes in a particular availability zone. So for SAP HANA, there is a feature called application volume group. So Azure NetApp file application volume group will allow you to provision the volume for SAP HANA in different IP address, and so that if there is some issue in one of the IP address, it basically doesn't impact the second volume. But now everything could basically deployed in a particular availability zone. So if we look into a primary and secondary database for SAP HANA, that could be deployed in a virtual machine scale set. And the application volume group for primary database is created on AZ1, and for secondary database, it is created on AZ2. So you could directly now create an ANF AVG into an availability zone, and it is a GA feature now. As we basically talked about different architecture, now I just wanted to touch upon one of the important aspects with regards to platform maintenance. So as I mentioned that on public cloud, there is an occasional downtime due to hardware or power failure. So there would be some issues at the host level, but we work effectively in a way that we want to make sure that the application, the customer workload is not impacted. So in order to basically help customers in such kind of events where there is a detection that host is having some issue because of some network degradation, or basically there are some patches that is applied that requires a reboot on that particular host. So in such events where a host requires certain kind of action at the fabric layer, we basically have basically a feature called Azure Schedule Maintenance, where uh, what happens is like an Azure identifies that there is some issue at the host level, and it notifies the VM about the upcoming maintenance to minimize this disruption. So this feature is available at the infrastructure level, and so we try to integrate this for the single point of failure component like database and central services. And for that, we have basically introduced a resource agent called Azure Events AZ, which allows to monitor the scheduled events uh, and then triggers the action accordingly. So what it does is like basically Azure detects up. So if I basically want to highlight the sequence of event that usually goes in place when there is an issue on the host. So what usually happens is like Azure detects a potential issues with the host and generate a scheduled events notification. So this notifications is basically sent upon all the virtual machine that is part of the host and allowing it to prepare for the upcoming disruption. So now we have configured, you can configure this Azure Events AZ in the pacemaker cluster, which monitors this notifications, and basically it when it identifies there is a certain notification from the host, it basically triggers a necessary action. So if suppose my node 1 is impacted because of some reason, I identify that there was this resource agent will identify an issue, and it will basically mark that node as unhealthy, and it will try to basically move all the resource in a seamless manner to another node. Once this node is basic means once all the resources are moved to another node, the VM could go down. Now this notification basically gives a lead time. It doesn't happen just by sending the notification. It's within 2 minutes. It won't basically go for a reboot. It gives a lead time for a resource to move to another node, and then once the resources are moved, it basically performs that execution. The event is basically executed. So this is how you can basically improve another important factor, like in terms of resiliency, by configuring this Azure schedule events. So all this thing which we talked about talks about the high availability perspective, how you can basically configure your SAP workload in a high availability fashion. But then you want to basically consider on how to basically set up a disaster recovery in case there is some natural disaster in a particular region where you want to basically start your SAP workload in a different region altogether. So if we look into a typical SAP workload, which basically use some application gateway, web dispatcher, have central service, application server, database layer, and then there are storage component like Azure Premium files, Azure NetApp files. So when we design this disaster recovery of SAP workload on Azure, we have to make sure that all these components are available on the DR side as well, to make sure that the application gets started smoothly without any issues. So if we look into a traditional key component when designing a DR for your SAP workload on Azure. So if we look into a typical SAP environment like SAP NetWeaver, which has database, central service, and application layer. Now, database and your central service are configured in high available component. So the high availability configuration requires Azure Load Balancer. It requires shared directories, which is running on NFS on Azure files or NFS on NetApp files or NFS cluster. And it has different functioning mechanisms. So all this high availability feature you need to take care when you are doing a failover on DR site as well. So I will look basically we'll talk about on this each component. So when and high availability setup is configured with Azure Load Balancer, you need to make sure that on the DR side, you have configured a new Azure load balancer, because you cannot replicate the Azure load balancer in that. And for the VM side, when you talk about database layer, we advise customer to use native database replication technology, where you basically use for HANA system replication to replicate your data onto different regions. And for application server and for central service, you could use Azure Site Recovery to replicate your SAP application server and central service. So now with regards to this ASR, it only replicates the managed disk. It won't replicate your NFS volumes that are running on Azure Files, Azure NetApp File, or NFS cluster. So you need to replicate these volumes, or you need to copy this NFS mount data to the target DR environment. So when you replicate your VMs onto the target DR environment using ASR, when you do a failover, you need to make sure that the VM comes up, the pacemaker configuration gets updated. So you need to basically adjust that pacemaker configuration based on as the IP address will change and things like that. So you need to adjust this pacemaker configuration when you perform the failover. And then there is a fencing mechanism. So as you are using different, based on your usage, you are using Azure Fence Agents, SBD, different kind of fencing mechanism. You need to make sure that on the DR side, similar fencing mechanism is available. So all this component needs to be taken care of when you are designing this DR architecture. So we have released different blocks covering all this scenario. You can check on that, and that will give you an idea on what all things to look after and what all changes that is required in order to in the SAP system after the failover. So now Sherry will be talking about how to what are the best practices for the reduced plant downtime.
Thank you. So next slide, please. And planned downtime very often is associated with maintenance. So Dennis already covered the enhancing availability during Azure scheduled maintenance. And there are other aspects. For example, if you need to upgrade the operating system or even the HANA itself running in the cluster. And now we provide the procedure to do the rolling update to HANA running in the cluster. So there won't be any downtime, right, for the HANA database. And for the on the security side, when you need to do the patching, right? And now we provide the live patching in both kernel and the user space. So we have a very particular use case for doing live patching to the HANA database in user space. And I have a slide to talk about that in the details. And the last one is when you maintain a cluster, right? Sometimes it can cause split brain situation. That's why we recommend that you want to, block the menu takeover through the HANA cockpit. So in the next slide, please. So I have slides on the details. So regarding the live patching, so for many years, SUSE has been supporting the Linux kernel live patches. And for the past 2 years, we have extended live patching to the user space, to applications and also the libraries. And in the user space, there is a particular use case is for the libraries. So the glibc and the OpenSSL, now we provide the live patches because they are the dependencies of HANA. Without those live patches, whenever you patch glibc and OpenSSL, you need to reboot HANA database. And that's a major disruption. So with live patching, now you can avoid reboot up to 12 months. And the user space live patching is only available from SUSE. And if you are running Slash for SAP, pay-as-you-go instances, the on-demand instances, the live patching is already included as part of the instance. So you can consume that at no additional cost. We also recommend that you use SUSE Multi-Linux Manager, aka a SUSE Manager, to manage, because it's much easier to identify the live patches, within the SUSE Multi-Linux Manager. Next slide, please. So regarding the integration between a HANA cockpit and so right now there is no communication or integration between a pacemaker cluster and the HANA cockpit, which means that if admin trigger a manual HANA takeover in the HANA cockpit, the cluster has no idea that it's on purpose, and in cluster would interpret that as a failure and try to remediate. So the end result could be disruptive. As a best practice, we recommend that you configure a hook that's provided as part of SLAS for SAP. Once you configure that hook, any manual takeover that's triggered in the cockpit would be blocked. That's for the better integrity, during the operations, to avoid any possible disruption. So this is not mandatory, but I would say this is highly recommended if you are running such combination. Yeah, next slide is security is another type of resilience in terms of reducing disruption from security vulnerabilities. And a lot of customers has been asking, what type of security hardening can I do right to enhance my SLAS for SAP instances? So the good news is we have produced a profile, using the rules from STIC and the CIS. Both are standard federal and industry security standard, and we have provided this new profile using based on the SAP workload. So we do a preliminary testing to make sure that there's no rule that could break the HANA database, because there are rules, when they are in place, the HANA would not start up. So we remove those rules, right, to make sure that HANA works properly. And so this profile has been released in the GitHub and the compliance as code. You can grab that profile and integrate with your data center standards. So you can review all the rules within that profile. Either you can remove some rules or even add your own rules. To provide the baseline, we have created pre-built images with those rules in effect, and those are available on Azure Marketplace. And when you check the Azure Marketplace, you can see that there are rules with the name hardened in the instance name. So those quote-unquote hardened images are the images with this profile in place. So I like to use the remaining time to provide a little bit update on the SLAS for SAP applications. First of all, is we have extended the life cycle of SLAS for SAP 15, and this is where the majority of the SAP customers are running on. Right now, we are on. We are now in the year 8 of the life cycle, and it's been extended into 2030s. So for customers, right, who is new, right, to 15, it means that there is an extended, runway to remain on. So this is a good reason that why the customers, right, like on 12. They want to upgrade to 15. And after all the efforts, there's still a very, a long runway to remain on. And in the meantime, we are working on the next major release, SLAS for SAP 16. So the anticipated release time would be around October or November timeframe. And so, when SLAS for SAP 16 is released, the first release would be Service Pack 0, and that has to be certified for HANA by SAP. And the certification won't start until the official release, so it's gonna take some time. Our goal is to have HANA certified on this release in early calendar year 2026. And then Azure would take that certified combination and certify all the instance types with SAP separately. So that means another couple months. So overall, right, based on the best practice, we don't highly recommend the customer to adopt the first version. So normally you would see mass adoption start at Service Pack 1, which is 16.1, and that would be towards the in the fall of 2026. But we like to provide some update as early as possible, for planning purpose. And as Dennis mentioned, the new HANA Resource Agent, SAP HANA SR-NG, would be the only HANA Resource Agent supported in 16. So which means that for the customers running the classic setup on 15, you can do two things. The first thing is you can either do an upgrade on 15 to NG first, then upgrade to 16. Or if you prefer to have a fresh deployment, you can start with a fresh deployment, on 16 directly. But in-place upgrade is not supported. And we provide various enhancement in 16. So for example, it would be browser-based installation and configuration, which makes the life of remote access easier. And we also provide Ansible automations for day 1 and the day 2 operations. And Ansible would be supported in /16, so the customers can leverage the Ansible playbooks that you may already have, or but we're gonna provide Ansible playbooks for the day 1 and day 2, the major tasks. And so there is a component called a Trento in Select for SAP, which is to monitor the configuration and the setup of especially the HANA clusters. The Trento started with support for HANA in the cluster, and now we have extended support to application layer, which means that ASS in the ERS running cluster can also be monitored by Trento. And we plan to provide deeper integration with SUSE Multi-Linux Manager, and also provide some operations, because Trento was initially released as a type of read-only tool. But based on the adoption and also the feedback, we're gonna provide support for some basic SAP operations. Next slide, please. And speaking of the in-place upgrade to NG, we have released the in-place upgrade guide, which is the second bullet. So please feel free to access that document, and it provides a lot of guidance on when do I need to do the upgrade. Whether, so for example, I'm now on 15, right? Do I need to upgrade now, or wait till I need to upgrade to 16 altogether? And what's the overall procedure, and how can I fulfill the prerequisites, things like that. Next slide, please. So speaking of Trento, it's a GUI tool, and you can install this binary. The installation binary is available in the Slash for SAP subscription, and we support Kubernetes-based and also RPM-based installation. And it provides, once you log in, right, it provides an overview of the healthiness of your entire SAP landscape. It can also detect all the instances running in your landscape and group them by seed. And it can also detect the underneath infrastructure. So in this screen snapshot, it detects that this landscape is running on Azure. And it also check the cluster configurations against the best practices in all the documents, including Azure documentation. So for example, Cluster has some special configuration at the Coral Sync layer based on the Azure environment. And we do have the Trento does have the intelligence, right, to check against that type of requirements. And there is already integration with SUSE Multi-Linux Manager, aka SUSE Manager. So at instance level, if there are new patches available that are of high priority, and you will be able to see the notification within Trento GUI. And in the future, we plan to provide a basic operation, which means that you can just do patching within Trento GUI as well. Right now, it's not possible. You have to switch to SUSE Manager or other tool, right, to do the patching. The overall value prop is, so this is the overall value prop that we, together with Azure, we provide day 1 and the day 2 tool sets. So on the Azure side, there is Azure SAP Deployment Automation Framework, SDAF, that can automate various deployment architectures, including the cluster setup. And once you move into the day 2 operations, within /4 SAP, we provide various components from auto scaling through Subtune to all the high availability cluster setup, and then the SUSE Multi-Linux Manager to ease the lifecycle management of all the /4 SAP instances, and also the live patching to reduce maintenance downtime, and the Trento to help validate and monitor the healthiness of the SAP landscape, especially for the at the cluster level, and then the security hardening that we already mentioned. Our components are well supported, right, on both the Azure native configuration and also SAP RISE on Azure. So if you have, so now we can, with the remaining time, we can open the Q&A.
Hi, okay, it looks like we have a few questions. So the first one is, given the recommendation for zonal deployment with VM scale sets on Azure, what are the key considerations and decision points for customers with existing workloads on availability sets?
Okay, so for customer currently running workload on a VT set, they do not have and do not want the cross-zone resiliency or a feature like on-demand capacity reservation, can continue to use a VT set. So there is no like you should move right away or you should be doing it, and a VT set won't be available. We don't have any roadmap like that. However, for the new deployment, we strongly recommend that you configure the VM in virtual machine scale set with FD equal to 1 across availability zones. And if a customer wants to increase the resiliency or wants to get a new feature, then and want to migrate their workload from AV set to virtual machine scale set, they could refer one of the blog that we have published, where we have developed a custom script to help customer to move their VMs that is deployed in AV set to virtual machine scale set.
And our next question is, what is the recommended approach for setting up disaster recovery on Azure?
Okay. So we talk a lot about the availability. So for resilient architecture, we recommend configuring DR across Azure region. Like while zone to zone DR within a single regions is available, and you could do that, but it basically it may not be sufficient. Like usually in an event of where a geography is having some challenges, like a natural disaster or something. So for that, we always advise like to meet this requirement for this mission critical workload like SAP system. We usually require high availability should be configured across availability zone using pacemaker cluster solutions. And for the disaster recovery, you should be using a different region altogether to ensure that your continuity for your business during zonal regional outreach.
And it looks like we have time for one more question, which is, what are the pros and cons of configuring SBD devices configured with ISCSI target server versus Azure shared disk?
Yeah, that's an interesting one. So yeah, so in Azure, we basically offer SBD, means SBD device and Azure Fence Agent. But even in SBD device, we have the ISCSI could be configured with ISCSI target server versus Azure shared disk. So now SBD device with ISCSI target server was the first one that we introduced on Azure, and it's been widely adopted by most of the customers that are using the SBD mechanism. Plus the ISCSI target server, you can configure that ISCSI target server once, and you could use it for multiple clusters. So if you have 5 SAP system with 5 pacemaker cluster setup, you could use a single ISCSI setup, target server setup, and you could basically mount it, host multiple SBD device on that. And on the DR side, if you want to make sure that on the DR side you can replicate this ISCSI target server using ASR, so you don't have to build the ISCSI target server from scratch on the DR side. You can replicate it using ASR. So the DR is simplified when you do that. But there are some cons with regards to this ISCSI target server. It's basically as you are configuring this ISCSI target server in virtual machine, you need to make sure that you patch this virtual machine based on your compliance requirement, which will add to the operational overhead. Plus, the thing is, like, as you are running in virtual machine, this will be adding cost if you have less number of pacemaker clusters in your portfolio. Now, if we talk about SBD device with Azure Shared Disk, so this is a newer and more simplified method for configuring SBD because this doesn't require any of the ISCSI target server setup, no need to deploy or anything, no need to deploy VMs or anything like that. You just configure Azure Shared Disk and attach that Azure Shared Disk on both cluster nodes. So we advise to use Azure Shared Disk ZRS, which will help you to have only one shared disk for your SBD device instead of the 3 SBD device which we recommend for the ISCSI target server. Now, the main advantage is, like, as we don't have VMs, you don't have to maintain or patch those VMs because this is just a storage device that you attach into it. So there's no additional operational overhead on the. Plus, for the smaller number of clusters, if you are having less clusters and all that, so it's more cost effective with smaller number of clusters. But then there is a few cons as well, like as Azure Shared Disk ZRS is not available across all regions. It is available in most of the hero regions, but still, if few regions it's not available. And if you are configuring a DR for your clusters for central services and you want to use ASR, it won't basically replicate the shared disk to the DR side. So what one has to do is, like, we need to create a shared disk on the DR region and then attach it, which will change the ISCSI ID. So you need to update the configuration of pacemaker in that as well.
Great, thank you. I think that's all the questions, all the time we have for questions right now. Thank you, Dennis and Sherry. Do you have any closing remarks before we end the webinar?
Thank you everyone for joining and have a nice day.
Yeah, thank you. If you have any questions, right, our contact info has been provided on the speaker slide. So please feel free to reach out to us.